Writing tests is the #1 hack for writing high-quality and bug-free code. That's why, in the next 11 minutes, I will break down everything you need to know about React testing. You will learn 4 core UI testing concepts by going through practical examples. By the end of the video, you will know how to add tests to your project like a pro. Before you write any tests, you need to understand what should you test. In short, focus on behavior, not implementation. Behavior is what your components do. For example, it may display a login button. Implementation is the details that are irrelevant to the users, like states, hooks, and reducers. Testing implementation details make your tests vulnerable. They'll break every time you refactor your code, even if the user experience doesn't change. That's one of the main reasons people aren't willing to write tests. With a better design, we can avoid this problem. Next, let's set up our testing environment. If you want to follow along, you can find all the code in this video on GitHub. Link in the description. Here, we have a React project I set up using Vite. We will be using Vitest for this project. By default, Vitest runs in a Node.js environment, but we want it to run in the DOM because we're testing the UI, so we need jsdom. Let's install both as dev dependencies. Now create a Vitest config file. Open the config file in your code editor and set the testing environment to jsdom. Next, go to the package.json file and set up a new script, test. What this does is when we call npm test, we will actually call npm Vitest. The flag UI provides a user interface in the browser that gives us information about the tests. If the flag is removed, then the test will only run in the terminal. Now let's write our first test. Here we have a simple button component. It takes a prop called signed in with the type Boolean. The button label changes with the signed in props. If signed in is true, it shows sign out. Otherwise, the label becomes sign in. Now, let's test this logic. Go to button.test.tsx. Here we're placing it in the same folder, but you can also create a separate test folder to store all the test files. The first step is to describe what you want to test. We want to test the button. By default, it should show sign in as the label. But if signed in is true, the button should change the label to sign out. To test the UI, we need 2 extra libraries, React Testing Library and jsdom. React Testing Library is used to render components, and jsdom provides some useful functions, so install them using npm and import them in the test file. The testing environment simulates what happens in the DOM, so first we render the button, then use screen.getByRole to find the button. It's kind of like query selector. In fact, you can use query selector to find the button, it's just not recommended because they are invisible to the user. More on that later. To test things, we write assertions to make sure that things align with our expectations. First, we expect the button to be present in the document, and it has the text content sign in. We use a regex here to do a case-insensitive match, so in the future this test is slightly less likely to break. Now, let's complete the second test case. When a user is signed in, the button should display sign out instead. The second test is very similar to the first one. The only difference is we're passing signed in as true to the button component. Then we check if the button's text content has changed to sign out. Now, let's run the tests. In the terminal, enter npm test. If you run it for the first time, you will be prompted to install Vitest UI. Just enter yes. Next, open this URL in the browser. Here, you will see details about our tests. We will be going through 5 tests in total, and since we haven't written tests for the other 4, they failed, which is normal. Click on the first test on the button component. You should see the first test has passed. But why does the second failed? There's nothing wrong with our code. This happens because of a bug with Vitest. You can learn more about it here. Here's how to fix it. Go to the Vitest config file and set globals to true. Now, if you come and refresh the page, you should see all the button's tests passed. One thing we want to avoid in testing is false negative, which means the code passed when there's a bug. One way to prevent that is to add bugs to our component deliberately and see if the tests still pass. For example, we can reverse the logic or not render the button at all. In both cases, the test should fail, which means that it catches the problem properly. Before continuing, here's a quick side note. We made a JavaScript course that combines learning to code and gacha gameplay. Our goal is to get people addicted to learning and leveling up their programming skills. If you know anyone who wants to learn JavaScript, share this with them. Link in the description. Some API like describe, it, and expect are used in basically all test files, so it would be really annoying if we needed to import it every single time. So let's simplify the import. The first step, which we have already done, is to set globals to true, and since we are using TypeScript, we have to add Vitest globals to the types field to tsconfig.app.json. If you wonder why there are 3 tsconfig files, This one contains the config of your React app. You can see here it includes every file in the src folder. It runs in the browser. This one is for vitconfig, which runs in the Node environment. And the tsconfig just links to the other two. Another thing we can do is to create a setup file, so we don't have to import jsdom in every file. Create a vitsetup.test file. Inside, import jsdom. Next, go to Vitest config and add the setup file path. Now we don't have to import API functions from Vit and jsdom. In the last example, we used getByRole to select a button, then used it to write assertions. This kind of functions are called queries. They may seem like query selector, but it's actually quite different. The role doesn't refer to tag name, it refers to ARIA role. ARIA role is an attribute used for accessibility. Many semantic tags have a default role. Here's a list of roles for elements you use often, but non-semantic tags like divs and spans don't have a role, so you can't select them by role name. Here's when you have to use other query methods. Now it's time to practice using different queries. Check out the status message component. This component displays the status message and the last updated date. We want to test if the messages are displayed correctly. So let's go to the test file. We use describe and it to organize the test. Then, render the component and pass in online as a prop. Now how do we select the message? If you try to use getByRole, you will see an error. This error occurs because, by default, span elements don't have a role. To solve this problem, we can either add a role to the span like this, which is a bad practice, or use getByText. GetByText allows us to select an element by its text content. Here, we want to do a substring match that is case insensitive. So create a regular expression like this, and pass in the I flag. Next, let's test if the updated date is displayed correctly. To select the paragraph element, again, we want to use a text match, but the problem is, date is a variable. How do we select that? The solution is to mock the system date, which means creating a fake time for testing. So, let's create a fake timer. We added in the before each API, so it runs before every test. After every test run, we restore the timer, so it doesn't affect other tests. Now, in the test, let's set the date to, let's say January 1st of 2025. After we render the component, we expect to see an element containing the correct date format in the DOM. It's quite common that there are multiple elements in the same role on the page. This shopping cart displays a list of items. Each item is an object with a name and price. Let's go to the test page. We want to test if the shopping cart renders all cart items. First, create a list of mock items. Pass it to the shopping cart. Next, we want to check if all the items are rendered on the page. GetByRole doesn't work because it throws an error if it finds more than one element. That's why we need getAllByRole. The only difference between getAllByRole and getByRole is it can select more than one item. For the assertions, we expect all the list items are rendered, and we expect the name and price of every item is displayed in this format. So, loop through the list items. Each list item should display the price and name of the item we passed into the component. So far, we have gone through the building blocks of UI testing, like queries and assertions, but we haven't tackled an important part, simulating user interaction. To do that, we need an extra library called user event. Install it using npm. Once you are done, check out the search input component. Here we have a text input and a cross button for clearing the input. The button only appears when the input is not empty. Let's go to the test file. First, we will verify that the input displays what the user has typed. Begin by selecting the search input. Before simulating any user interaction, we must run a setup function. Now we can simulate a typing event. Notice that this function is asynchronous, so we need to add the async keyword here. After the user types React testing, we expect the search input to contain the exact value. Next, let's test if the clear button works as expected. First, the button should not be visible when the input is empty. In this case, we can't use getByRole because we know the button is not present in the DOM. And getByRole throws an error when it can't find the element. Instead, we will use queryByRole, which returns null when it can't find the element. Next, we ensure the input is empty by default, and the button is present in the DOM. Second, the button should appear when the input is not empty. We could create another test block, but it makes sense to extend the first test. Let's select the button and click the button. If it works, the button should clear the input value. In this last section, we will go through a more complex example. It combines our previous learnings and another core concept, mocking. Check out this user registration form component. You don't have to understand every line of code, just understand what they do. It contains a form with email and password inputs. Then there's a register button, which on click will trigger form submission. When submitted, the form sends a post request to the server. It displays either a success or failure message based on the response. Now, How do we test this component? We can categorize the tests into two parts. First, we test if all the components are rendered correctly. Second, we want to test interactions with the API. First, let's make sure the user can interact with the form. The form elements, including the two inputs and the submit button, should be rendered. To select input and form elements, there's a handy query called getPlaceholderByText. It selects the element by its placeholder attribute. Next, a button click should 1. Submit the form, and second, send an API request with the right data. API request is unreliable, but in a testing environment, we want consistent input and output. To guarantee a consistent API response, we must mock the API request. To do that, we need an extra module called MSW. So let's install that. After you're done, go back to the test file. Here's how to set up an MSW server. Define a server URL and run the setup server function. Inside the setup server function, define a handler. We use this handler to mock the API request. Whenever we make a post request to this endpoint, this handler will replace it and return a predefined response. The server configuration requires 3 key steps: starting the server before running tests, resetting the handlers after each test so we can use different handlers for different tests, and closing the server after all tests complete. Now that we have set up the server, let's test the form submission. After we put our form on the screen, we fill in the email and password fields and click the submit button. When the request is successful, it should display a success message. But we can't do a normal assertion because the API request is asynchronous. We need the wait for function. What it does is that if the expect function throws an error, it will continue to wait until it succeeds or times out. And when the request is successful, it should display a success message. This way, we can test that the whole form works without making real network requests. Lastly, we want to test the scenario where the API request failed. To do that, we have to replace the default handler with a failed response. Use the server.use function from MSW. Then, let's mock a response with a failure message and return a status of 400. Then we set up the form like before and check if an error message appears on screen. If it does, we should be able to find an element that contains the text, "Registration failed."